for looking for these objects. Not just radar, but visual sighting, infrared sensors, telescopic evidence. Now we have multiple sightings by multiple modes.
Imagine waking up to news that something from beyond the stars is racing toward us. An object so fast its speed defies everything we know about the cosmos. This isn't science fiction. On July 1st, 2025, astronomers discovered 3I Atlas, a mysterious interstellar visitor traveling at 137,000 mph. But it's not just its speed that's shocking. Its chemistry breaks every known rule. Is this an alien probe? A cosmic weapon? 3I Atlas is forcing us to question everything, challenging our understanding of the universe itself.
Got Dr. Michio Kaku joining us right now, the theoretical physicist, author of The God Equation, much more. Genius is he, and kind enough to join us. Doctor, these images are stunning, and I know we're told we're only getting the smallest of the smallest percentage in. Much more to come.
For decades, scientists have theorized that objects from other star systems might occasionally pass through our solar system, but until now, we hadn't witnessed one so close, and certainly not one that raised so many questions. The discovery of 3I Atlas, much like its predecessors, was a remarkable event that seemed to offer a glimpse into a larger, unexplored cosmos beyond our solar system. But this wasn't just another comet or asteroid. The unusual properties of 3I Atlas, its incredibly high speed, its unique chemical composition, and the strange trajectory it was following would soon have experts asking whether this object could be something more than just a wandering space rock. The story of how 3I Atlas was discovered begins at the Atlas telescope in Chile. As part of a routine survey on July 1st, 2025, astronomers working with the telescope noticed something faint moving against the backdrop of the Milky Way. At first, it seemed like just another speck of light, something unremarkable in the vastness of space. However, a closer examination of the data revealed something far more extraordinary. The object's speed, 137,000 miles per hour, indicated that it was not part of our solar system. It was moving too fast for the sun's gravity to capture it, meaning it was on a hyperbolic trajectory, one that would carry it straight through our solar system and out into interstellar space, never to return. Within hours, astronomers from around the world had started confirming the findings. From Hawaii to South Africa, telescopes locked onto the object's path. The result was clear. 3I Atlas was the third interstellar visitor ever detected. This object, larger and faster than anything we'd seen before, was not like any other comet or asteroid observed in our solar system. The discovery had stunned the global scientific community, and for a brief moment there was a sense of exhilaration, as if this was a moment of cosmic lottery, an event that only a few generations of scientists would ever witness. But as astronomers looked closer, the object began to defy more than just expectations about its speed. Its chemical composition raised even more red flags. In the world of comets and asteroids, there are certain things that we expect to see. Certain gases, certain compounds, certain patterns of activity. When the James Webb Space Telescope began gathering data on 3I Atlas in August 2025, it revealed something completely unexpected. The object was venting carbon dioxide at an extraordinary rate, far more than the water vapor we typically find coming from comets. In fact, it was releasing carbon dioxide at a ratio of 8:1 compared to water vapor, which was unlike anything ever recorded in a comet before. To put that into perspective, most comets in our solar system typically release far more water than carbon dioxide. Even outliers, which might have unusual chemical compositions, rarely exceed a 2:1 ratio of CO2 to H2O. But 3I Atlas was venting 129 kg of CO2 every second, compared to just 16 kg of water. This was the highest CO2 to water ratio ever observed in any comet. For the scientific community, this was more than just an interesting anomaly. It was a sign that the object's origin might be much stranger than anyone had previously thought. Scientists had several theories. One possibility was that 3I Atlas had formed in a distant star system beyond what is known as the CO2 ice line, where temperatures are cold enough for carbon dioxide to freeze, but water remains scarce. Another possibility was that intense radiation or some other exotic process had stripped the water from the object, leaving carbon dioxide as the dominant gas. While the team at the James Webb Space Telescope, led by Martin Gordon, modeled various scenarios to explain these findings, none of them fully accounted for the data. The conclusion was that 3I Atlas might have originated in a place or under conditions unlike anything seen in our own solar system. Perhaps it came from a time when the galaxy was still forming, or from a hotter, more massive star system than ours. But the surprises didn't end there. In July 2025, the Very Large Telescope in Chile detected something even stranger. It found clear lines of atomic nickel coming from the object, but strangely, there was no trace of iron. In the typical behavior of comets in our solar system, nickel and iron are often found together, forged in supernovae and released when comets heat up, but 3I Atlas was venting nearly 5 grams of nickel per second, with no sign of iron, something that defied all known patterns of comet chemistry. The implications of these findings were profound. If 3I Atlas was not made up of the same building blocks as comets in our solar system, where had it come from? Some suggested that it might be composed of organometallic compounds, like nickel tetracarbonyl, which could break down at lower temperatures than iron. Others proposed that cosmic rays, over billions of years, might have stripped iron from its surface. Still, the timing of the appearance of nickel before cyanide gas, which usually occurs in the expected sequence of comet outgassing, added another layer of mystery. In essence, 3I Atlas was rewriting the rules of comet chemistry. As the data continued to pour in, speculation about the object's true nature began to spread. Headlines exploded across the internet, with some even suggesting that 3I Atlas might be an alien probe or some kind of cosmic threat. Videos, many of them sensationalized with AI narration and footage of telescopic images, went viral. However, much of the true science, like the anomalous clickbait headlines and the missing iron, was buried under the flood of clickbait headline. It was a familiar pattern, one that had occurred throughout history whenever something unusual from the cosmos appeared. This wasn't the first time a comet had stirred up panic. In 1910, Halley's Comet, for example, caused widespread hysteria when it was found to be releasing cyanogen gas, a toxic substance. Newspapers of the time warned that the gas might poison the Earth's atmosphere, and people rushed to buy gas masks and comet-proof umbrellas. In 1908, the Tunguska event, a massive explosion caused by a 50-meter object that detonated over Siberia, sparked fears of cosmic destruction. Today, algorithms on social media amplify similar fears, but the actual scientific explanations often get drowned out by sensationalism. Despite the sensationalized media coverage, the truth remained that 3I Atlas was challenging everything we knew about comets. Its path through our solar system was another piece of the puzzle that set it apart. According to calculations from Harvard's Avi Loeb, 3I Atlas's approach was incredibly precise, making its trajectory seem almost too perfect, as if it were designed to observe multiple planets. However, the odds of it passing so close to planets like Mars, Venus, and Jupiter were incredibly low, only about 1 in 20,000. While most astronomers would still consider this a coincidence, the improbability of it all kept the debate alive. What did all of this mean? For some scientists, 3I Atlas was more than just an object from another star system. It was a time capsule, a remnant from the galaxy's past. Its speed, its chemistry, and its trajectory pointed to an origin deep within the Milky Way's thick disk, where stars are up to 10 billion years old. Oxford's Chris Lintad and Matthew Hopkins estimated that 3I Atlas likely predates our solar system, having wandered for more than 7 billion years, possibly flung out by gravitational chaos in a star system that no longer exists. For astronomers, 3I Atlas was a chance to look back in time, a glimpse into the early history of our galaxy. It was carrying chemical clues from before Earth even had oceans, from a time when the sun was still a young star. In just a few short months, we had gathered more data on 3I Atlas than we had on any other object that had passed through our solar system. But the real question remained, what did this object mean for us? On July 1st, 2025, a significant discovery was made by astronomers using the Atlas telescope in Chile. The telescope, part of a network dedicated to monitoring the skies for new objects, detected a faint streak moving against the backdrop of the Milky Way. What initially appeared to be just another speck of light quickly became something far more intriguing. After a closer examination, the data revealed that this object, which would later be named 3I Atlas, was not like anything astronomers had seen before. Its speed, at a remarkable 137,000 miles per hour, indicated that it was not part of our solar system. It was moving far too fast for the sun's gravity to hold it, meaning it was on a trajectory that would carry it straight through the solar system and out into interstellar space, never to return. This discovery sent shockwaves through the scientific community, as it confirmed something that astronomers had long suspected but never witnessed in person. Interstellar objects do exist, and they can travel through our solar system. 3I Atlas became only the third confirmed interstellar visitor in history, following the first two, Oumuamua in 2017 and Boris in 2019. However, what made 3I Atlas particularly fascinating was not just its status as an interstellar object, but its size, speed, and the strange features that would soon captivate astronomers worldwide. The discovery was quickly confirmed by a network of observatories across the globe. Within hours of the initial detection, telescopes from Hawaii to South Africa began tracking 3I Atlas's path. The data was consistent. This was no ordinary comet or asteroid. The object was moving so fast that it was already beyond the sun's gravitational influence, and it was set to pass through the solar system and continue its journey into interstellar space. This was an object from another star system, and the fact that it was so close to our own neighborhood was a huge surprise. Its path would bring it nearer to Earth than any other interstellar object detected before. In the days that followed, astronomers around the world turned their attention to 3I Atlas, eager to learn as much as they could before the object passed beyond our reach. For a brief moment, there was a sense of exhilaration within the scientific community. The discovery of an interstellar object, especially one moving so quickly and passing so close to Earth, was an extraordinary event. It was a reminder that our solar system is not a closed system, but a region of space that can be traversed by objects from other star systems. The implications of this were profound, and the excitement over the discovery quickly turned into a race to gather as much data as possible before 3I Atlas disappeared from view. The first team to confirm the discovery was led by Larry Deno and John Tonry at the University of Hawaii, who had been monitoring the skies for interstellar objects. Once they detected 3I Atlas, they began plotting its trajectory and quickly realized that it was on a hyperbolic path, an arc that was unbound by the sun's gravity. This meant that the object would pass through our solar system and continue on its way, never to return. The astronomers were able to track its course in real time, confirming that it was an interstellar object, not one that had originated from within our solar system. As more data was gathered, the international network of observatories began to form a clearer picture of 3I Atlas's path. The object was moving so fast that it would not be captured by the sun's gravity and would not enter into an orbit around our star. This was a key detail in confirming that the object was truly from another star system, as it was traveling at a speed that exceeded the sun's gravitational pull. This object was not just passing through, it was on a one-way journey that would carry it out of our solar system and into the vastness of interstellar space. The excitement over the discovery was palpable, and the scientific community began to share the data they had gathered. Telescopes from around the world had locked onto the object's path, and for a brief moment, 3I Atlas became the focal point of the astronomical community. As it moved closer to Earth, astronomers scrambled to gather as much information as they could, hoping to learn more about this strange object before it vanished from view forever. In the midst of this excitement, astronomers began to realize that 3I Atlas was unlike any interstellar object they had observed before. Its speed, while impressive, was only the beginning of the mystery. As the object neared our solar system, its composition and behavior started to raise even more questions. While the initial data confirmed that 3I Atlas was an interstellar object, it was the details that followed that would soon leave scientists stunned. One of the most striking features of 3I Atlas was its incredible speed. At 137,000 miles per hour, it was traveling at a speed 55 times faster than a bullet fired from an assault rifle. This was mind-boggling by any standard, but it was especially remarkable when compared to other objects within our solar system. Even NASA's fastest spacecraft, the Parker Solar Probe, travels at a fraction of this speed. The sheer velocity of 3I Atlas suggested that it was a projectile flung from another star system, likely ejected by some catastrophic event billions of years ago. Perhaps it had been launched by a violent collision between planets, or by a chaotic planet formation process. Whatever the cause, the speed of this object carried with it an immense amount of energy. Energy equivalent to thousands of nuclear bombs. Fortunately, the object's path kept it clear of Earth, but the power behind its movement made astronomers uneasy. The idea that something moving so fast, with such immense energy, could pass so close to Earth was unsettling. It reminded scientists of the power of the universe and the potential dangers that lie beyond our solar system. But beyond the immediate concern over its speed, it was the object's unusual composition that would soon capture the attention of the scientific community. In August 2025, the James Webb Space Telescope, JWST, began to gather more detailed data on 3I Atlas. The information it provided would take the mystery of this object to an entirely new level. The JWST's first full spectrum of 3I Atlas revealed a surprising finding. The object was emitting an enormous amount of carbon dioxide, far more than the typical water vapor that is usually found in comets. For comparison, most comets in our solar system release far more water than carbon dioxide. Even outliers rarely exceed a 2-to-1 ratio of CO2 to water. But 3I Atlas was venting carbon dioxide at an astounding 8-to-1 ratio, a number never before observed in any comet. This raised immediate questions. Why was 3I Atlas releasing so much carbon dioxide, and what did this tell us about its origins? Scientists immediately began to theorize about the possible causes behind this unusual CO2 release. One theory was that 3I Atlas had formed in a distant star system beyond the CO2 ice line, where temperatures are cold enough for carbon dioxide to freeze, but water remains scarce. Another possibility was that some intense radiation or exotic process had stripped away the water from the object, leaving carbon dioxide as the dominant gas. While the team at the JWST, led by Martin Cordner, modeled various scenarios to explain these findings, none of the explanations fully accounted for the data. The most likely conclusion was that 3I Atlas had originated in a place unlike anything found in our solar system, possibly from a hotter, more massive star system, or a time when the chemistry of the galaxy was still in its infancy. But the surprises did not stop there. In July 2025, the Very Large Telescope, VLT, in Chile detected something even stranger: clear lines of atomic nickel, but no iron. In the known patterns of comet chemistry, nickel and iron are often found together, forged in supernovae and released when comets heat up. But 3I Atlas was venting almost 5 grams of nickel per second, with no trace of iron. This was another unexpected anomaly. Scientists were left scrambling for answers, with some suggesting that perhaps the nickel was locked in organometallic compounds that broke down at lower temperatures than iron. Others proposed that cosmic rays over billions of years might have stripped the iron from the object's surface. Whatever the explanation, the absence of iron was just another piece of the puzzle that made 3I Atlas unlike any object we had ever encountered. 3I Atlas was following a hyperbolic path, which meant that it wasn't bound by the sun's gravity. This was one of the key pieces of evidence confirming that the object was from another star system. The speed at which it was traveling, 137,000 miles per hour, was far too fast for it to be captured by the sun and enter into an orbit. It was not coming to stay. It was just passing through, destined to continue its journey into interstellar space and disappear from view forever. This was not a fluke or a random event. The object was moving with such precision that its path seemed almost calculated, as if it had been designed to observe our solar system. What stood out even more was the object's close approach to several planets in our solar system, including Mars, Venus, and Jupiter. Harvard's A.V. Loeb, a well-known astrophysicist, calculated the odds of 3I Atlas passing within close proximity to these planets, and the results were shocking. The chances of this occurring were extraordinarily low, only about 1 in 20,000. The precision of the trajectory seemed almost too perfect to be the result of a random natural process. This led to some fascinating speculation. Could this be a cosmic fluke, or was there something more deliberate behind its path? Was 3I Atlas somehow designed or guided to observe multiple planets in the solar system? Despite the improbability of the object's course, the scientific community could not dismiss the possibility that 3I Atlas was behaving in a way that was far too precise to be random. Its trajectory had been so accurately calculated that it seemed as if the object was purposefully moving through the solar system, passing by planets in a specific order and at the right moments for observation. This was an unusual feature that astronomers had not expected to find in a random interstellar object. It raised the question, If 3I Atlas wasn't just a cosmic accident, what could its purpose be? However, the mystery deepened when astronomers realized that the object's closest approach to the Sun was occurring behind the Sun, making it impossible for Earth-based telescopes to observe it during its most active phase. This fact added a sense of urgency to the race to gather as much data as possible before 3I Atlas continued on its journey out of the solar system. The timing of its closest approach was incredibly frustrating for researchers, as it meant that the object would be hidden from view just as it reached its peak activity. In spite of this, the observations that had already been made were remarkable. The fact that 3I Atlas was passing so close to Earth was itself a significant discovery. Never before had an interstellar object come so close to our planet. While it posed no immediate threat, the presence of such a massive object passing through our solar system had profound implications. It was proof that the boundaries of our solar system were not as solid as we once thought. Our solar system, previously thought to be a closed system, was now shown to be permeable, capable of being visited by objects from other stars. This realization was revolutionary for astronomers, as it meant that our solar system was not an isolated entity, but was part of a much larger cosmic network. In addition to the questions raised about its trajectory and potential purpose, the object's speed also added to the sense of awe and unease surrounding 3I Atlas. Its hyperbolic velocity was not just remarkable for its speed, it was a sign that this object had traveled a long distance before reaching us. The fact that it was moving so fast meant that it had been ejected from another star system, likely billions of years ago, during some catastrophic event or collision. This object traveling at such extraordinary speeds carried with it a vast amount of energy that was difficult to comprehend in practical terms. The sheer power of this interstellar visitor reminded scientists of the vast, uncontrollable forces that exist in the universe, forces that are beyond our understanding and often beyond our ability to predict. As the data from the various telescopes poured in, another intriguing aspect of 3I Atlas began to emerge. It wasn't just its speed and trajectory that were causing a stir among scientists, it was also the object's peculiar chemistry. The object's emissions, as previously mentioned, were dominated by carbon dioxide in a ratio that had never been observed in a comet before. But there was something even stranger: the presence of atomic nickel without any detectable iron. This anomaly baffled scientists who had never seen this combination of elements in a comet or asteroid before. In our solar system, nickel and iron are often found together in comets and asteroids, as they're both formed in supernovae and are released when the objects heat up. But 3I Atlas was venting nickel at an astonishing rate without any iron present. This was a puzzle that scientists could not easily solve. Some researchers proposed that the nickel might be locked in organometallic compounds that broke down at lower temperatures than iron. Others suggested that cosmic rays, which have been bombarding the object for billions of years, might have stripped the iron from the object's surface. Regardless of the explanation, the lack of iron in the object's emissions was another key feature that set 3I Atlas apart from anything scientists had ever encountered. This chemical anomaly added to the growing list of mysteries surrounding the object, leaving scientists with more questions than answers. At the same time, the internet was abuzz with speculation about 3I Atlas. Social media platforms and online videos began circulating, with many people speculating that the object might be something other than a natural space rock. Some even suggested that it could be an alien probe sent by an advanced civilization to observe our solar system. These theories, fueled by sensational headlines and viral videos, quickly overshadowed the scientific explanations that were emerging from astronomers and researchers. While the scientists were focused on the object's unusual speed, trajectory, and chemistry, the public was captivated by the idea that 3I Atlas might be some kind of extraterrestrial artifact. The internet's reaction to the discovery of 3I Atlas was not unlike the public's reaction to previous astronomical events. Throughout history, comets and other celestial events have sparked panic and speculation. In 1910, Halley's Comet caused widespread fear when it was discovered that the comet's tail contained cyanogen gas, a toxic substance. Newspapers at the time warned that the gas might poison the Earth's atmosphere, leading people to buy gas masks and comet-proof umbrellas. Similarly, the Tunguska event in 1908, when a large object exploded over Siberia, sparked fears of cosmic destruction. Today, the rise of social media has amplified these reactions, and the public's imagination often runs wild when faced with such extraordinary events. However, while the internet was busy spreading wild theories, The real scientific work was being done by astronomers who were diligently working to understand what 3I Atlas truly was. As the research into 3I Atlas continued, the scientific community began to consider the bigger picture. The object's speed, chemistry, and trajectory pointed to an origin far beyond our solar system, possibly from a star system that no longer exists. Some scientists believe that the 3I Atlas could be a relic from the early days of the galaxy, carrying with it clues about the formation of the universe and the stars that came before our own sun. If the object had indeed been ejected from its original star system billions of years ago, it would have carried the story of that system with it. In a way, 3I Atlas became a time capsule, a cosmic artifact that could provide insights into the early history of the galaxy. In August 2025, the James Webb Space Telescope JWST provided the most detailed observations of 3I Atlas yet. The findings from the JWST spectroscopic analysis revealed something truly remarkable. The object's emissions were overwhelmingly dominated by carbon dioxide, far exceeding the amount of water vapor typically found in comets. This ratio of carbon dioxide to water at 8:1 was completely unprecedented. In the context of our solar system, comets usually release far more water than carbon dioxide, with only a few outliers even approaching a 2:1 ratio. To find a comet-like object from outside our solar system releasing carbon dioxide in such high concentrations was a major red flag to scientists, suggesting that 3I Atlas had originated from somewhere completely different, somewhere beyond our known cosmic boundaries. This discovery led to widespread speculation about the origins of 3I Atlas. One hypothesis proposed that it could have formed in a star system located beyond the CO2 ice line, a boundary in space where temperatures are low enough for carbon dioxide to freeze, but where water ice would remain scarce. This region would be too cold for water to freeze, leaving carbon dioxide as the dominant frozen compound. Such an environment could have allowed 3I Atlas to form in ways that we couldn't have anticipated based on the chemistry of comets in our own solar system. However, the more astronomers examined the data, the more apparent it became that there were still gaps in the explanation. It seemed that 3I Atlas had come from a place or a time that was fundamentally different from our own solar system, possibly even from a time when the galaxy itself was still in its formative stages, before the chemical processes we were familiar with had fully evolved. Yet this was only the beginning of the surprises that 3I Atlas had in store. In addition to the discovery of the high carbon dioxide to water ratio, astronomers observed something even more bizarre. The object was venting an unusually high amount of atomic nickel, but curiously there was no trace of iron. In our solar system, iron and nickel are usually found together, especially in comets and asteroids. When comets pass through our solar system and heat up due to the sun's radiation, they often release iron and nickel in nearly equal amounts. However, 3I Atlas seemed to defy this pattern. Instead of the usual combination of iron and nickel, the object was venting nearly 5 grams of nickel per second, with no trace of iron whatsoever. This anomaly puzzled scientists, who could not explain why this object, coming from another star system, would behave in such an unusual way. Several theories emerged to explain the absence of iron in 3I Atlas's emissions. One suggestion was that the object's surface might be composed of organometallic compounds, such as nickel tetracarbonyl, which could break down at temperatures lower than those required to release iron. This theory suggested that the unusual chemistry of the object could be due to the specific conditions of its formation, possibly in a star system much hotter or more massive than our own. Another hypothesis proposed that the object had been bombarded by cosmic rays for billions of years, which could have stripped the iron from its surface. Cosmic rays, which are high-energy particles traveling through space, can interact with the surface of objects over long periods of time, slowly eroding them and changing their composition. However, the timing of the appearance of nickel before cyanide gas, which is typically released later in the sequence of cometary outgassing, only added to the confusion. Nothing about 3I Atlas's chemistry seemed to follow the usual patterns we expected to see. In many ways, 3I Atlas became a symbol of how much we still don't know about the universe. It wasn't just a new object passing through our solar system, it was a cosmic enigma that defied our most basic assumptions about the nature of space, time, and matter. As the data from the various telescopes and satellites continued to flow in, the mysteries surrounding the object only deepened. Every new piece of information seemed to suggest that 3I Atlas was part of a much larger and more complex story than we had ever imagined. Its path, speed, and chemical composition all pointed to something ancient, something older than the Earth, the Sun, and even the galaxy itself. Despite the enormous amount of data that had already been gathered, some of the most significant findings about 3I Atlas were still to come. By using the Gaia star catalog, astronomers were able to trace the object's motion against a backdrop of more than 1 billion stars. What they discovered was nothing short of astonishing. 3I Atlas was moving at an incredible velocity, far faster than any object we had ever observed within our solar system. And its trajectory was pointing to a region of space that was part of the Milky Way's thick disk, an area populated by stars up to 10 billion years old. This meant that 3I Atlas was likely not a young object, but one that had been traveling through space for billions of years, carrying with it a history that predated even the formation of our solar system. In fact, researchers at Oxford University, including Chris Lintad and Matthew Hopkins, estimated that there was a 2/3 chance that 3I Atlas had originated more than 7 billion years ago, long before the Earth and Sun even existed. This new information painted a picture of 3I Atlas as a relic from the galaxy's past, a cosmic time capsule that had been flung out of its original star system by some catastrophic event or chaotic planetary formation. Perhaps 3I Atlas had once been part of a star system that no longer exists, its origins lost to the vastness of time and space. Yet, despite its ancient past, 3I Atlas was still carrying with it chemical signatures from a time before Earth had oceans or even continents, long before life as we know it could have existed. For astronomers, 3I Atlas was more than just an object of study. It was a window into the ancient history of the galaxy. It was a glimpse into a time when the universe was still forming, when stars and planets were still in the process of being created and destroyed. By studying 3I Atlas, scientists were able to peer back in time, looking at the chemical makeup of an object that had witnessed the birth and death of stars over billions of years. The object's journey through our solar system was not just a random event, it was a moment in time that connected us to the deep past of our galaxy and reminded us of how little we truly understood about the cosmos. As more and more data came in, it became clear that the 3I Atlas was not just a cosmic curiosity, it was a scientific breakthrough. It was an opportunity to learn more about the formation of the galaxy, the origins of interstellar objects, and the processes that govern the behavior of matter in the cosmos. For the first time, scientists had the opportunity to study an object that had traveled from another star system, carrying with it the secrets of a time long before Earth was even a concept. 3I Atlas was a cosmic messenger, bringing with it clues about the early days of the universe, clues that could help us understand our place in the cosmos and how the universe itself has evolved over billions of years.